I'm Ashley Fevers, and I'll talk about atoms and elements. So to let you understand how small atoms are, just think about this. Atoms are about 20 million times smaller than a single grain of sand. They consist of even smaller subatomic particles. Protons and neutrons. Positively charged protons and uncharged neutrons occur in the atom's core, or their nucleus. Negatively charged electrons move around the nucleus. And a charge is an electrical property. So, opposite charges attract, and the like charges repel. A typical atom has about the same number of electrons and protons. The negative charge of electron is the same magnitude as the positive charge of proton, so the two charges can cancel one another out. And here's an example. The atomic number is located on the top left corner, so 26. The mass number is on the bottom left, so 55.845. And the element symbol is Fe for iron. So you're probably asking yourself, why do we need to know this? Knowing this helps us predict how the elements will behave. The periodic table is an arrangement of all known elements by their atomic number. So I have here the periodic table. Isotopes and radioisotopes. All atoms of an element have the same number of protons, but they can differ in the number of other subatomic particles. Isotopes are those that differ in the number of neutrons. The total number of neutrons and protons in the nucleus of an isotope is the mass number. Mass number is written as a superscript to the left of the element symbol. Alright. The most common isotope of carbon has 6 protons and 6 neutrons. So, another naturally occurring carbon isotope has 6 protons and 8 neutrons. So it would be like this. Carbon-14 is an example of radioisotopes, or radioactive isotopes. Atoms of radioisotope have an unstable nucleus that breaks up spontaneously. As the nucleus breaks up, it emits radiation. And that's a process called radioactive decay. The atomic nucleus cannot be altered by ordinary means, so the radioactive decay is unaffected by external factors such as temperature, pressure, or whether atoms are part of a molecule. Each radioisotope decays at a predictable rate into predictable products. For example, when carbon-14 decays, one of its neutrons splits into a proton and electron. The nucleus emits electron as radiation. Thus, a carbon atom with 8 neutrons, 6 protons, carbon-14, becomes a nitrogen atom with 7 nitrogens and 7 protons. So, 14. This process is so predictable that we can say with certainty that about half the atoms in any sample of carbon-14 and nitrogen-14 atoms after 5,730 years. The last thing I'm going to touch up on are tracers. Alright, so all isotopes of an element generally have the same chemical properties, regardless of the number of neutrons in their atoms. This consistency means that the atoms of one isotope behave the same way inside organisms as atoms of another isotope. So radioisotopes can be used as tracers, and tracers are substances with detectable components. So radioactive tracers are widely used in research. So in conclusion, I hope from this little PowerPoint you got to understand that all matter consists of atoms, tiny particles that turning constant of electrons moving around the nucleus, so the core, and protons and neutrons are components of the atomic